Imagine being surrounded by information, but unable to access it independently. Printed documents, signs, labels, and classroom materials are everywhere, but for a visually impaired person, much of this information remains out of reach. What if a smartphone could transform the visual world into touch? This is Pocket Braille Vision EA, future concept combining artificial intelligence, mobile technology, and a compact tactile braille device to make everyday information accessible anywhere. As part of this concept, I built a web-based system that can process almost any image. The user simply uploads a photo and selects one of three modes. Read text mode detects and extracts visible text such as information from documents, signs, labels, or classroom materials. Describe image mode explains the important objects, people, surroundings, and actions shown in the image. Smart mode automatically analyzes the image and decides what information would be most useful to the user. Once the analysis is complete, the information is sent to the tactile device. For this prototype, I am using an ESP32 connected to 6 servo motors. The ESP32 receives the generated text and controls the servos to display each braille character through 6 moving tactile dots. This demonstrates how artificial intelligence, mobile technology, and a compact tactile device could work together to make visual information accessible through touch. Here, I am demonstrating the tactile button system in action using a custom 3D printed frame. An image uploaded through the web application is first analyzed and converted into text. That text is then translated into Braille, and the ESP32 controls 6 servo motors to raise and lower the tactile dots for each character. This is currently a proof of concept prototype. A future version could run entirely through a mobile application using a simple shortcut key. A visually impaired user could point the phone camera at a document, sign, label, or object, press one button, and receive the information through a compact, tactile braille device. The final product could provide a practical and portable way for visually impaired people to access visual information independently. This system could help visually impaired students access textbooks, classroom notes, diagrams, signs, and learning materials more independently. By converting visual information into Braille, it can support inclusive learning and give students faster access to information both inside and outside the classroom. Here, the ESP32 C++ code runs in the background, receives each Braille letter pattern, and sends the correct commands to the servo system. I have added 3D printed tactile buttons to demonstrate how this concept could work in a physical device. This prototype shows how digital information can be converted into touch, allowing visually impaired users to receive information through Braille. I believe a system like this could improve independence, support inclusive education, and make documents, signs, labels, and learning materials easier to access. A compact and affordable version could help people with visual disabilities interact with everyday information more confidently, without always depending on another person.